55, I'm looking at 10 and 11 right now. 10 and 11. First thing, diameter CD, perpendicular to chord AB. Need somebody to tell me what's going on. All right, what's going on in my diagram right now? This is a theorem from this unit. If I have diameter CD perpendicular to chord AB, somebody tell me what's going on in this circle right now. Boom, there it is. Here we go. Start us off right. Here we go. 16. Start us off. What's going on in that diagram? If I have diameter CD perpendicular to chord AB. Correct. So which segments are congruent, Thomas? There you go. That may be helpful. AE congruent to EB. Diameter perpendicular to chord bisects the chord. All right, let's hop on 10 now. AB is 16. So Thomas just told us, what can I label each piece now? 8 and 8. CE is 16. Woo. What's the length of ED now? That little piece. It's not a radius, so that's not going to help. Do you guys see two chords in that diagram? Do you see two chords in that diagram that intersect? Name the two chords that intersect for me. 17, name the two chords that intersect. CD and AB intersect, meaning their parts, when I multiply them, when I multiply their parts, they're equal to each other. All right, so let's hear from 19. Name one chord for me in here. Name one chord. Okay, what are the two parts it's broken up into? Okay, so 16 times X. Name another chord for me. 22, what's the other chord? Oh, that's a good chord. 7, another good chord. 12, how about a chord, the other chord? AB, what's AB broken up into? Okay, there we go. So that's how I could solve this one using what we did on Tuesday. So what I have there, 16x equals 64. X equals 4 spot. By yourself or in your group, you're on number 11 now. By yourself or in your group, you're on number 11. CD is still perpendicular to AB, though. CD still perpendicular to AB. All right, what'd you set up for me? 15, you're up. What'd you set up for this one? 10 times 10, the two parts of this chord AB, and 2 times X. Got it. So we got 50. CE, got it. Okay, any issues there? Because now what we have to talk about is how do I find the length of a secant and a tangent today? You guys know the deal with two intersecting chords now. What's the deal? Now you can go back to your notes. Day 12, what's the measure of a tangent and a secant? So you know what I'm going to be looking for today. I may be looking for the length of AC in that first diagram. I may be looking for the length of BA in that first diagram. That's what I'm looking for, the length. We're not doing angles anymore. We're done. That was quiz 2. All right, now I want to find the lengths of these. I'm going to give you the theorem. I want to see if you can somebody can apply it to the diagram. Here's the theorem. Tangents and secants. To find the lengths of them, here's what I use. Whole times external. Do we know what the word external means first? Because that would be, okay, that would be problematic if I asked somebody and they didn't know. Whole equals whole times external. That's all I got for this. That's all I got today. Use my diagram. Those are what, by the way? ABC and ADE. Remember what we called those? Secants. Okay. 8, give me a whole one. Great job. Just everything just stops. A halt. 14, give me a whole secant. Okay. CA times, ready? The external part. 13, the external part. BA, yep. So CA times BA will have the same value as, go to the other secant. Name the whole secant there. 25. EA times its external part. 28, don't have one, I know. 7, oh, we're on fire already. I'm getting 28, I'm getting fired up now. 26 times DA, thank you. Yep, there you go. The one thing I do not want you to do here, because remember what we just left off with. Oh, that part times that part equals that part times that part. Guys, that is for chords only. Don't start doing this to me. Oh, this times this equals DA times ED. No, that's for chords. We're in a different realm here now. Whole times external equals whole times external. All good. All right, well, what if your diagram looks like that? What's BCD? Secant and BA, tangent. I'm still using whole times external. Here's what it would look like, though. Secant, what's the whole secant? 25, can you name the whole secant? DB. Whole times, here we go, external, 21. BC. All right, don't get all crazy on me here, the next couple people I ask. Go to the tangent now. Whole tangent. 15, whole tangent. External part. 23. Same thing. When you're working with the tangent, the whole and the external are the same. So you studs in here, if you wanted to simplify this a little bit, whole times external equals, what can I just do over here now? AB squared. Yep, the tangent squared. Okay? So that's what we're going to finish it up with here today. Whole times external equals whole times external. All right, what do you got in you? Here we go. If we have to round, it's going to be to the nearest tenth. See, this is when I start getting fired up already, because I already know kids are, oh, 5 times 10 equals 4 times x. They're not chords, though. They're not chords. All right, so I have to do whole times external here. All right, I only can do part times part with the chords. 22, give me a whole secant up here. God. 21, give me a whole secant. Okay, 15 times its external part. 19. 5. All right, watch out. Next secant. How can you express how long the entire thing is on the next secant? 26. X plus 4. Thanks, Jack. And then times its external part. What do you got for me? 19. 4. There we go. Everyone all right? Whole times external equals whole times external for secants and tangents. I think you can handle this, huh? 65 equals 4x plus 16. Maybe if I could do it. Four x equals, oh boy, we're going to have to round here. Yes, no? $59 divided by 4, 14.75 equals x. It said nearest tenth, though. Read your own directions, Carlino. 14.8. Anything you want to ask here before I keep trucking? Because this next one here, not going to be a big fan. The last one and we have to do today, you're not going to be a big fan of, but don't care. 3, give me a whole something up here. 11, nice, the secant. 11 times its external part. Oh, 21. 2 equals, go to the tangent now. Whole and external of the tangent, 25. And y. So y squared. Everyone see that with the tangent, whole and external, same piece. So y squared equals 22. Yep, we're going to take the square root of that sucker and round to the nearest tenth. 4.7. Feeling good about this, huh? Until we get to, well, actually 3 is not bad either. It's when we get to 4 and 5. All right, let's roll. 3. Watch your mouth when you give me holes. 24, give me a whole something here. Y plus 8, I like it. Y plus 8. What would be the external part of that secant? 24 again. Now let's roll. 8. He took the easy one. Now somebody's got to do the harder one. Not really that bad, but what's the other secant? The whole one. 11, your time. Come on, can we combine some like terms there? Thank you. Y plus 10. And then how about the external part of that secant? What do you got for me there? 3. What do you have for me? 7. Go ahead and distribute. No rounding needed here. Y equals 6. Any discussion before we got to really buckle in right now? To find, okay, ready for 4. Find x and y. Ooh, we got a lot in there. I see secants. I see a tangent. See some chords in there. Whew. Well, what do we start off by finding first? Well, we have to start out by finding. Here's why. Take a look. There's not a choice. You have to find x first. Here's why. Let's say if you chose y first. Y is a what? Tangent. So you're going to go, all right, y squared equals. Now when you tell me the whole secant, what's it going to have in it? An x in it. And I don't want a y and an x in the same equation. So we are going to have to find x. What's your plan there, champs? How do I find x? Because you can't say whole times external here because you're going to have a y in it. I don't want to do that. You got a way to do it here. Christian, want to let us know? There's chords that intersect. This is what we just did on Tuesday. Hey, look, you got RP and you got NM that intersect each other. And we know their parts are equal. So set up something to find x right now. Oh, I'd like to hear from 14. Set up something that solves for x. You see the 2 chords that intersect, Caleb, correct? Okay. Name me the 2 parts of one of them. Okay, so 3.2 times 10, and what about the other two parts? 4 and x, yep. Hey, we see how we're applying some review material here. I should say review, we just did it 2 days ago. That's how I'm going to find x. 32 equals 4x, x equals 8 now. Okay, now you can do whole times external on the tangent and the secant. $12, give me a whole secant or a whole tangent. I don't care where we go here. 12, hold on though. 12 would be the whole secant? 18, everyone see I'm putting 18 as the whole secant. 6 plus 8 plus 4. 18 times the external part, which is 6. And then what am I writing for the tangent? Y squared. What is that, $1.44? 108. Geez, I'm off today. And the directions are still near. I got to change those for next year. We should be doing simplest radical form right now, but square root of 108 to the nearest tenth. 10.4. Anything you want to ask? Because I'm going to give you a minute to yourself before we go to number 5, because I don't think you realize what's coming at you here in a second. Looks like an easy diagram. I'll have to do whole times external, but all right, here we go. Here we go. Round to the nearest tenth. $22. Can you please set up the first half of this equation?
Not here.
Oh, good, good. We're off to a good start. 22, off to a good start again. 27, here we go. I just want half of it, any half. Like what goes on this side? Whole times, I want a whole times external from you. You're doing part times part on me. Whole times. Okay, so I got 2 whole, 2x plus 4. What's the external part? Okay, times x. And then somebody take care of the tangent for me. 18, take care of the tangent. 10 squared, yep, or 10 times 10. 2x plus 4 is the whole secant. X is its external part. So, when I distribute, what do I have here? 2x squared plus 4x equals, yikes. This is why this is a brutal one. Your next move. Subtract 100 over, yeah, I got to get one side equal to 0 because you know what possibly could be coming up here. Your next move. We can take a 2 out. Yep, that's fine. We can take a 2 out. Could we take the here? Sure. Yeah, you're still going to move that 50 over. So now we're left with x squared plus 2x minus 50. You guys trying to search for some numbers now? What numbers you searching for that do what? Multiply to negative 50, but add to 2. I'll wait. Would anybody like to report those numbers back? If anybody's going to raise their hand, I'm going to tell them put it down. Those numbers do not exist. There are no 2 numbers that multiply to negative 50 but add to 2. They don't exist. All right, but okay, I can't factor it, but I can still solve it. And I realize we haven't done this in a couple units, but what's our other option? Especially you guys that don't like the factor, period. Quadratic formula. Here we go. Yes. X equals. Oh boy. Negative b plus or minus square root b squared minus 4ac all over 2a. Yes. Before we do anything, what's your a value up here? 1. How about your b value? 2. And be careful here, your c value. The sign travels with it, negative 50. Good job. X equals, what's plugged in for negative b? What was your b value? 2, so this will be x equals negative 2 plus or minus. We'll talk about that radical in a second. All over, what's in the denominator? 2a. 2 times 1, so 2. Anybody remember what I suggested to do to find the number underneath the radical? Store. So everyone, let's remind ourselves how to store. How do I store 1 in for a? Everyone hit 1. Everyone see your store button right above the on button. And then alpha math, which will give you an a. So 1 stored in for a. 2 stored in for b. Alpha apps. And negative 50 stored in for c, which is alpha program. And then all you're going to type in your calculator once you have a, b, and c stored is b squared minus 4ac. So alpha b squared minus 4 alpha a alpha c. Do we all get the same number underneath the radical? Let's find out. What number is showing on your screen? 204. That is the number that goes underneath. All right, last step. You're going to get 2 answers. Negative 2 plus the square root of 204 divided by 2. And how do I get my other answer? Negative 2 minus the square root of 204 over 2. I would highly recommend, if you have a calculator right now that's got a fraction template, use it. And just type each one in. Type each one in, and then we're going to round to the nearest tenth. If you do not have a fraction template, no big deal. Do this numerator first, and then take that decimal and divide by 2 if you don't have a fraction template. And then we got to talk about your answers. All right, so just check my work too. I'm getting 6.1 as one answer. And over here, I'm getting negative 8.1. You want to discuss any of it? Because I can't be done here. Claudia? I can't have a negative length, right? Cannot have a negative length in my diagram, so that's gone. So I'm leaving it as 6.1. 4 problems. Hey, 4 problems. That's what I'm asking for in 10 days. 4 problems.